Alright guys, so what we're going to be looking at today is solving word problems using inequalities as opposed to just equations. When we have inequalities, it often can change the type of answers we have. We can actually have multiple answers a lot more commonly in this situation, although not always. But there's a simple process for it. It's very similar to what we did before. First, it's important to identify the given and the desired information, figure out what you know and what you want to know. That will help us to establish algebraic relationships. That's writing the inequality, thinking about what we want for variables, and how we have to connect variables and values and operations. Guessing and checking and generalizing is acceptable, but you have to get to that generalization part. You cannot simply guess and check your answer and get it that way. The key is it needs to be algebraic. That's what we're working on here. Once you have that established, you're just going to solve. We know how to solve inequalities. And then at the end, you will check. Not only check your math, but also just check to see that your answer makes sense and that it fits into the criteria of the question itself. Alright, so we're going to look at two example questions, and hopefully they just give you some insight into how to solve these word problems. So the first one here is not really a real-world situation. It's just written out verbally here. You want to find all sets of 3 consecutive even integers whose sum is between 19 and 36. So the key words here are that we have 3 consecutive even integers, and we have a sum, which means we're talking about addition, and that sum has to be between 19 and 36. And so what we do here is we set up an inequality, and we first want to think about what are 3 consecutive even integers. Well, if we have 3 consecutive even integers, let's say, just come up with an example here. We've got 8, 10, 12, something like that. We have this list right here. We could add those and we'd see that 8 plus 10 is 18, plus 12 is 30. So actually that's going to be one of our solutions because 30 is between 19 and 36. But that's not the point. The point is, how does this help us get our variable? Well, to get from the 8 to the 10 and then the 10 to the 12, each time I'm adding 2. So my first number is x. My next number is x plus 2. My final number, adding 2 to that, would be x plus 4. So those are my 3 consecutive even integers. It actually would be the exact same setup if I was looking at consecutive odd integers. It would still be x, x plus 2, and x plus 4. And if it was more than 3 consecutive even integers, I could add an x plus 6 or whatever, go from there. Alright, so now let's set up our inequality. I want to find the sum of these numbers, so I'm going to take x, I'm going to add that to x plus 2, and add that to x plus 4. Oops, let's clear that up a little bit, sorry about that. And now it says it has to be between, so I think it has to be bigger than 19, less than 36. So I could certainly write it as 2 different inequalities, or I can actually physically stick it in between the 19 and the 36. Now the common question here would be, does between mean including? What we're going to say is that when we say between, we are talking strictly between. So between 19 and 36 means it can't equal 19 and it can't equal 36. And so therefore we will not include an or equal to here. We're going to keep it just as it is. Alright, so then I've got 19 is less than, I'm just going to simplify my interior. That's 3x plus 6 is less than 36. And rather than splitting, I'm just going to subtract 6 from all 3 sides, the left side, the right side, and the inside. That leaves me with 13 is less than 3x, which is less than 30. And dividing by 3, we'll finish solving this inequality. Now, x is left on the inside and 10 is left on the right side. 13 thirds is nothing that's really obvious. It doesn't come out nicely. So I'm actually just going to leave it as 4 and 1/3. It's 4.3 repeating. There's a reason that I'm going to do that. It's going to be pretty helpful for me. So looking at that, what that says is that my value x, which I originally described as my first of 3 consecutive even integers, has to be between 4 1/3 and 10. And so if I think about the even integers between 4 1/3 and 10, it actually will narrow down my choices. So x could equal, certainly 4 wouldn't work. 4 is not greater than 4 1/3. 5 is odd, so I have 6 would be my next option. And then after that, I could have 8 would be my next even integer, and then after that would be 10. But the problem with that is 10 is not less than 10, which is one of the requirements of the inequality. So I actually have only 2 options for x, which is my first number. Now I have my other 2 numbers, and so I have, if 6 is my first, then 8 and 10 would be my other 2 consecutive integers. If 8 is my first, then 10 and 12 has to be my other 2 consecutive integers. Now you may think that these actually violate this rule down here, but remember that this 10 was only bounding the x. The other 2 integers are x plus 2 and x plus 4. So as long as my starting point, the 6 or the 8, is between 4 1/3 and 10, then I'm okay. So I have my solutions. Now I just want to check. Does this set of 3 consecutive even integers, which they are, 6, 8, 10, does that have a sum between 19 and 36? Well, 6 plus 8 is 14, plus 10 is 24. 24 works. And the next one, 8, 10, and 12, we actually already checked that. We got that was 30, so that one works. And just to make sure that we did our math correctly, we could try the next set going up and the next set going down. If we went down, we'd be looking at 4, 6, 8, which would actually have a sum of 18, not between 19 and 36. And if we went up, we'd have the set 10, 12, 14, which would have a sum of 36. And so, since we said originally that we had to be strictly between 19 and 36, the set 10, 12, 14 would give us a sum of exactly 36. That wouldn't satisfy it. And certainly then if you added a larger number, it would increase even more. But that's the idea. So that's those are our 2 answers. There are 2 sets of 3 consecutive even integers whose sum is between 19 and 36, and they are 6, 8, and 10, and 8, 10, and 12. All right, so that was our first crack at it. Watch it again if that didn't make much sense, and but hopefully it did. All right, let's see another example. All right, so this is definitely much more of a real-world example here. Mr. Callan is ordering t-shirts for the math team, and each shirt costs $15. But if the order exceeds 12 shirts, then the price per shirt for all shirts drops by 20 cents for each shirt over the dozen. So for example, if 13 shirts are ordered, 13 is one more than the 12, and so we're going to have one 20-cent discount. And so each shirt, all 13 of them, would now cost $14.80 a piece. At least how many shirts would Mr. Callan have to order to have the shirts cost less than $12.50 each? Okay, so what we're really looking for here is trying to establish how many shirts we're ordering. And so that's probably what we're going to want our variable to be. So I'm even going to write that out. I'm going to say x equals the number of shirts. That's just going to help me when I come back to this at the end. And so now I'm going to try to set up an algebraic relationship. I know the starting point, and each shirt originally cost $15. And then I'm going to have a discount here. Discount means I'm taking away from the price. So that tells me I have a subtraction. And the discount is going to be 20 cents multiple times. So I'm going to have 0.20. And how many times am I applying that discount? Well, it's going to be for every shirt sold except for the first 12. So if I sell, like I said in the example, 13 shirts or buy 13 shirts, and that's one 20-cent discount. If it's 15 shirts, that's three 20-cent discounts. So I actually want to take the number of shirts that I'm ordering and just ignore the first 12 in terms of discounting. That's going to be something that's not gonna help me out there. The first 12 don't give me a discount. Only the next however many do. And now I want that to be less than $12.50 each. So I'm going to just use that inequality. Say it's less than 12.5. I don't need to use the 12.50. I could if I want. And now I just solve this inequality. I have a negative 0.20 that needs to be distributed. So I'm going to have 15 minus 0.20x plus negative times a negative gives me the plus, and 0.2 times 12 is 2.4, which is less than 12.5. Combine the 15 and the 2.4 gives me 17.4 minus 0.20x is less than 12.5. Now I'll subtract 17.4 from each side. Negative 0.20x is that's going to be less than 4.9, negative 4.9, excuse me. And so now to solve this, now we could divide by negative 0.20 if we had a calculator, or maybe another way to think about that is multiplying by negative 5, because that would cancel it out, but let's assume we have a calculator. Divided by negative 0.20, and it's going to give me x. Now I divided each side by a negative, so I need to make sure I flip my inequality. And 4.9 divided by 0.2 is 24.5. And so I go back to my original statement, and x is the number of shirts. So I need to get a number of shirts that is greater than 24.5. So what's the least number of shirts that I'd have to get? Well, I have to think about this. Shirts, I'm not going to order half of a shirt. And so what's bigger than 24.5, but then the least number I'd have to get, I'd have to order at least 25 shirts. Maybe I'll mention at least there. At least 25 shirts is what I would need to order. And we can go back and just kind of do a check here. If I order 25 shirts, that's 13 more than the 12 that's required to trigger the discount. And so 13 times, I'm going to take 20 cents off the cost of the shirts. That's a $2.60 discount. $2.60 off of $15 would bring the price to $12.40, which is certainly less than $12.50. I think it's pretty clear that if we had one less shirt, and therefore one less 20-cent discount, the shirts would cost $12.60 each, and therefore would be too expensive for this problem. Now I do want to mention something about this inequality that we've set up here, the 15 minus 0.20 times x minus 12. This part of it tells you the price of the shirts based on ordering x shirts. However, it's inexact. It only really works for a certain amount. For example, if I ordered one shirt here, 1 minus 12 would be negative 11, which would mean that I'd actually have, when I multiply by the negative 0.20, it would in effect raise the price by 20 cents 11 times. But the shirts cost $15 each, so I wouldn't actually be adding that on. So this inequality really only works once x gets to 12. And then at the same time, we can't continue this forever. For example, if I ordered 112 shirts, that would be 100 20-cent discounts. Well, 100 20-cent discounts is going to be a little bit too big because I'm pretty sure that I'm not going to be able to be getting these shirts for negative $5. So there's certainly going to be some limitation on this, and that's something to keep in mind, that we have to be realistic. But in this case, it seems like 25 shirts is a reasonable answer, so we're still in good shape. All right, so this is a little introduction. Hope that makes sense, and that now we're ready to do a little bit more in class.